Alright, so I give you the first year sketch. Explosion, I think is the title. I don't know. Explosion.
Good evening, esteemed colleagues and guests alike. I'm very proud this evening to announce the results of some recent research of great importance, both for Berkeley and the physics community as a whole. Although leaps and bounds have been made over the last several decades in promoting the participation of women in physics, the playing field is still far from level. This is reflected in all aspects of our field, from the number of tenured faculty to the composition of each year of new graduate students. However, this evening marks a sea change in this ongoing effort. Ladies and gentlemen, I am proud to present the first ever class of Berkeley physics graduate students to equally represent men and women. A gender ratio task force led by Professor Bernard Sagelet struck upon a brilliant solution which could be immediately implemented. However, what you see before you is only the first step. In just over a week's time, we will surgically reassign the gender of these students before you. Note that to avoid any gender bias, we proportionally reassigned as many women as we have men. Unfortunately, although this procedure is not covered by the student health insurance plan, some of our most talented experimentalists have offered to perform the surgeries free of charge in the sub-basement of Burge. Don't worry, liquid nitrogen is one of the best local anesthetics known. Our initial results have been so overwhelmingly positive that our task force has recommended reassignment for the entire department, a very progressive step unique to the Berkeley atmosphere. Our department will be the first to be completely gender balanced. So watch your inboxes in the coming weeks for an email from Donna with your gender reassignments. Let's make history, Berkeley!
Have you seen this absurd new article by Nielsen and Minamaya on how the Higgs is going to send causal ripples back through time to prevent its own discovery?
Well, I know a time-traveling Higgs sounds like a crazy idea, but I have devised an experiment that will allow us to detect a time-traveling Higgs if it does exist. I just need to print out this paper. Oh. Printers are broken. What? Oh.
You have to get the same fix.
Be sure to tune in next Thursday when we have Nobel Prize-winning physicist George Smoot on Who Wants to Beat Up on Fifth Graders?
Hello, class. My name is Corey Ganor. In my field, we set C equal to 1, so you can call me Ori. In this class, Physics 209, we will be learning classical electrodynamics. A quick note on grading. You will have weekly problem sets worth a total of 2% of the final grade, and a final exam worth 98%. Yes?
Professor Ganor, don't you think that's a little bit ridiculous?
You bring up an excellent point. We'll do it 50-50 instead. And now let's move on to electromagnetism. We'll begin by writing down Maxwell's equations. Now, before we do that, let me make a brief parenthesis. You see that we can combine the three fundamental constants in an algebraic manner to form dimensionless quantities such as the Planck length, which comes into play when we will consider quantum gravity later in the semester. And you see, we can produce other dimensionless constants of interest, such as, yes?
Professor, what does this have to do with ENM?
An excellent question, which reminds me, I wanted to discuss the unification of the electromagnetic and the weak interactions. Now, moving on to relativity. If we write down the field strength tensor, we can clearly see that in the Lorentz gauge. How many of you have seen this before? About half. Okay, well, this is boring. Let's talk about relativistic hydrodynamics. Now, when we consider the stress energy tensor,
What's this? A minus sign I see? Well, now it's a plus.
yes? You can call me Ori.
Oh, okay, Ori. I think you have a sign error in that equation over there.
Let me check my notes. Yes, right there. And a factor of 2 pi here. No, not there. Over here. I'm going to absorb the 4 pi into the C. This also should be a second derivative. And not a minus, but a plus. And a plus. What was I saying? Anyway, when we consider the stress energy tensor of a perfect relativistic fluid, it becomes perfectly clear how this will lead us into a discussion of field theory. Let's discuss one more thing, then we'll go get the turkey, or the say tofu thing if you're vegetarian, but people made fun of me at the holiday party last year for saying that. We can better understand the quadruple moment by assuming 23-dimensional space-time. And then we can tie 2 strings together to form a bow. Alright, now, after 14 weeks, I'm getting really tired of the saxophone music. So I think it's time we move on to discuss a new topic, electrostatics.
And now Erwin Schrödinger to accept his Nobel Prize in Physics.
I'm very honored, and I'm only sad that my cat wasn't here to see this today.
I'm really happy for you. I'm going to let you finish. But Heisenberg had one of the best theories of quantum mechanics in the world.